Welcome to your third lesson in your independent unit. This is a video tutorial on permutations. We're going to start off by asking the question, how many ways can you arrange the letters A, B, C? So I'm going to start off with A, B, C, A, C, B. I'll then move to B being my first letter, B, A, C, B, C, B, B, C, A. Lastly, C, A, B, and C, B, A. So it appears that there are 6 ways that we can rearrange the letters A, B, C. Now for those of you who've done your factorial notation homework and your counting principles homework, you will know that because we had 3 letters, we could have done 3 slots, 1, 2, 3, and in those slots we could have put down the number of choices. So in our first slot, we had 3 choices to choose a letter. After we chose one letter, there'd be 2 left, and then there would be 1 left. And so we can get 3 times 2 times 1, which using our factorial notation we know is 3 factorial, or it would be 6. 3 times 2 times 1. So what we actually just did is called a permutation. It's an ordered arrangement of all or part of a set. And some real life examples would be telephone numbers, license plates, passwords, because we know that if there's a different order, we know that it becomes a different, for example, telephone number. An arrangement of objects or people in a line is called a linear permutation. So for example, how many ways can you arrange 7 different objects in a row? Well, since we have 7 different objects, we'd have 7 different slots, and it would be 7 choices, 6, 5, 4, 3, 2, 1, and so we would end up with 7 factorial. In general, for n objects, the number of permutations is going to be n factorial. Thus, if you were arranging 5 people in a row, it would be 5 factorial. Now, as I'm going to slide this up, if there are R items to be selected from a set of n objects and put in a specific order, then the number of permutations, there's a formula, and it looks like this, NPR. What that means is the arrangement of n items taken R at a time. And it looks like this, n factorial divided by n minus r factorial. So you'll recognize your factorial notation. You're now going to see why 0 factorial is defined as 1. That was in your very first lesson but wasn't explained. So we're going to use the formula. We're determining the number of ways we can arrange 7 different objects. So we're going to go 7p7, and we know that our n is right here. We're going to get 7 factorial over 7 minus 7 factorial, which is going to give us 7 factorial over 0 factorial for now. So for this to exist, it must be defined as 1, and thus giving us our 7 factorial, which would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, let's look at our first example. In a game involving letter tiles, Eva drew the letters A, W, L, N, S, O, and D. How many permutations of 4 of these letters are possible? So we've got 3 actual different ways that we can do this. In our first method, method number 1, let's use the formula. So we're going to choose the formula 7p4, which is going to give us 7 factorial over 7 minus 4 factorial, which ends up giving us 7 factorial over 3 factorial. Now using our factorial notation knowledge, we're going to expand this. 7 times 6 times 5 times 4 times 3 factorial. And the reason why I left the 3 factorial there is that these are now going to cancel off. And if we multiply 7 times 6 times 5 times 4, we're going to end up with 840 ways. So that's our first method, using the formula. Our second method, method number 2, is using our counting principles idea. So I have 4 letters, so I will need 4 slots. And then I look at the choices. For my first letter, I have 1, 2, 3, 4, 5, 6, 7 choices to choose from, any of those letters. After I've chosen 1, I only have 6 left. Then I've chosen 2, I only have 5 left. And then for my very last letter, I would have 4 choices left. And once again, you see 7, 6 times 5 times 4, which is also going to give me 840 ways. The third way, method 3, is using your calculator. Use a calculator. And so we're going to go 7p4, which should give us our 840. And I'm just going to bring my, I'm going to clear that, so I'm going to show you where I got it from. If you hit your math key on your Texas Instrument, if you have a graphing calculator, you hit the math key and you slide it over to probability. If you see number 2 there, it says NPR. So first of all, we're going to quit that and we're actually going to go, I forgot, you have to choose 7 first, then go to math, go over to probability, down to 2, and then you're going to choose 4, or have 4. So the 7 there is the N and the R is the 4. You hit enter and you end up with your 840. So for those of you that don't have graphing calculators, you should see an NPR button. You may have to put it in the 7, then the nut button, and then the 4. That's most likely. Let me know if you have questions on that, which is going to give us our 840. Okay, let's do that question one more time. We're going to use all 3 methods to determine how many different ways 3 people can be seated in 10 desks. So the first way would be to use the formula 10p3, which is 10 factorial over 10 minus 3 factorial, which gives me 10 factorial over 7 factorial, which is 10 times 9 times 8 times 7 factorial, all over 7 factorial. So these are going to reduce, and you're left with 720. I can also use my counting principles method. I've got 3 people, or 3 people that need to be seated. So when they first walk into the room, the first person would have 10 choices of a desk, the second person would have 9 choices of a desk, and the third person would have 8 choices of a desk, or of desks, which also gives 720. And last but not least, if we go back to our calculator and go 10 permutation 3, you see we get 720. So 10p3, 720. We can also combine the formula with factorial notation to solve equations. So for example, you'll see we have 2 sides here and it asks us to solve. So we're actually looking for the n. Now you can do guess and check for some of them, but you will on a test have to show your work. And so we're going to get n factorial over n minus 2 factorial, converting this into the formula, is equal to 30. I'm going to now do some expansion like you did in the first lesson on your own, and I'm going to remember when you expand you always subtract 1 when you're expanding factorial notation. So I'm going to get n times n minus 1 times n minus 2 factorial. That's good news because n minus 2 factorial is also in the denominator and those are going to reduce. That's now going to leave me with, I'm going to simplify this, distribute my n, get n squared minus n. I'm going to also, that equals 30. I'm going to bring everything over to one side. I now have a quadratic that will easily factor for me. N minus 6 and n plus 5. That's going to give me n equals 6 and n equals negative 5. And as we know, you can't choose 2 from negative 5, so this is going to disappear and you're left with an n value of 6. So if you had 6p2, it would give you a value of 30. Now, those are just straightforward permutations, but permutations, there's also a lot of different types. Now, unfortunately, the permutation formula doesn't work for a lot of these types, and you have to use the blanks and fill in your number of choices, as we would do with counting principles. So the first type of permutations are those with restrictions. So it says, using the first 10 letters of the alphabet, how many ways can you arrange them if you must start with a vowel? Now, the easy thing with restrictions is that if you're given a question with restrictions, fill in your restriction choices first. Fill in restriction choices first. And then you can continue on the question like we would normally do. So there's 10 letters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We must start with a vowel. So this has to be a vowel position. So let's list those first 10 letters that we'd be choosing from. A, B, C, D, E, F, G, H, I, and J. So if we look, we have 3 vowels out of the first 10 letters of the alphabet, so we would have 3 choices. Now, once we've chosen a vowel for the first one, it doesn't matter what we put in the other blanks. So we would have 9 choices left, 8, 7, 6, 5, 4, 3, 2, 1. Now some of you may want to write this simply as 9 factorial. And for ease of sake, I'm going to just leave the answer as 3 times 9 factorial. Sometimes on the test I'll ask you not to simplify if you don't have your calculator portion, and this would be a totally acceptable answer. Now we'll add one more restriction, if you must start and end with a vowel. So once again, let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but now we have to have a vowel at the beginning and a vowel at the end. So we'll fill in our restrictions again. We have 3 vowels to choose for the first spot, then I'd only have 2 vowels left in the last spot. Once I've used 2 letters, let's say I cross off the E and the I, I'd have 1, 2, 3, 4, 5, 6, 7, 8 left. And so I would then get my 8 factorial. So 3 times 2 is going to give me 6 times 8 factorial, and that will give me my answer. Okay, let's turn the page. Example number 5 says, if there are 6 chairs in a row, how many different ways can 3 boys and 3 girls sit if they must alternate? So we'll draw in our 6 chairs, 1, 2, 3, 4, 5, 6, and let's start off with boy. So we'll go boy, girl, boy, girl, boy, girl, because they must alternate. So we've got 3 boys to choose from. I'll put in the boys right away. I'd have 3 choices for the first boy, 2 choices for the second boy seat, and 1 choice for the last. And then the girls, I would have the same thing, 3 times 2 times 1 in my choices. So 3 times 3 is 9, times 2 is 4. That's going to give me 9 times 4, which is 36. Now, it did say they must alternate, but it didn't say we had to start with a boy. So we have an OR question, which you learned in your counting principles means addition. So we're going to add it to a separate occasion. In this case, we're going to go, I'm going to rewrite the 6 seats, but I'm going to start with girl, boy, girl, boy, girl, boy. It turns out I'm going to have the same choices, right? 3 girls, 2 girls, 1 girl, 3 boys, 2 boys, 1, all with multiplication because we need all of them. And once again, it's going to give us 36. So 36 and 36 is going to give me 72 ways. So there's 72 different ways 3 boys and 3 girls can sit if they must alternate. So those were our restrictions. The next one are permutations requiring cases. The first example says how many 4-digit numbers are even using the digits 0, 1, 2, 3, 4, 5, 6 with no repetitions. Now, the problem here is that, well, we always have to be careful with 0 because we have a 4-digit number. So we have to be careful that we don't put 0 at the beginning and end up with a 3-digit number. And because of that, we're asking if this question, or if the number, is even. We know then that it either has to end in 0, 2, 4, or 6 for it to be even. Like I said, though, the 0 causes problems because we don't know if it gets chosen at the end or it doesn't get chosen at the end. So we need to break this up into cases. And so case 1, it's going to end in 0. And so we're going to have a 4-digit number, so 1, 2, 3, 4, and we're going to say it ends in 0. And we then know for sure. So for example, we know that this is going to end in 0, so we have 1 choice. It then means that we can choose any of the other numbers, 1, 2, 3, 4, 5, or 6 in our first position. So I would have 6 choices, then once I used up something else, I'd have 5, and then 4, which when you multiply is going to give you 120. Now, the second case is it ends in 2, 4, or 6. 1, 2, 3, 4. So we would have 3, so this has to be a 2, 4, or 6 to make it an even number. And so we're going to have 3 choices here. So let's say I chose the 6. I'll just cross that off for right now. Now we have to be careful. We can't use 0 when we're going to go choose our first digit for the first place, because if we did, we'd end up with a 3-digit number. So what we're going to do is this is going to exclude 0. So now if I cover up the 0 and I've already used the 6, I got 1, 2, 3, 4, 5 choices. However, now once I get into the second one, let's say I use the 3, the 0 will come back into play. So this will include 0 again. And now I have 1, 2, 3, 4, 5 again. So it repeats because the 0 was excluded in the first digit but included in the second.